So we'll go over it for the next 25 minutes, and then we'll go over it like the first 20 minutes of class on Thursday. Then we'll be on to new things. The real exam's next Tuesday, right? All right, let's take a look at it. So practice exam number 2, question 1. This is all about breaking up the cake with the various parts. These are some of the hardest ones, these cake ones. All right, Carly's eyes. The strawberry quarter the cake is worth. Okay, so we're talking about Carly and how she values things. How does Carly feel about things? She values strawberry and banana equally, but chocolate twice as much as either strawberry or banana. Okay, this is a particularly tricky question because there's, if you like something like chocolate or whatever, twice as much as you like strawberry, then it's twice as valuable to you, right? And then if there's also twice as much chocolate, it's 4 times as valuable to you. Do you realize that? It's twice as valuable just because you like even if there was the same amount, if there was the same amount of chocolate and the same amount of strawberry, and you like the flavor of chocolate twice as much, then the same amount of chocolate will be worth twice as much to you. So double the amount of chocolate is going to be worth 4 times as much to you. You realize that? So in other words, let me do this. Let me do this to make it simpler. I would put a line right there. So they're all 4 the same size. That would make it easier. Let's just, so forget about all that other stuff I said. I mean, it was true, but how about this? Just make them all the same size. So now all 4 pieces are the same size. I can't tell which is, this is banana? Yes, this is banana, strawberry, right, chocolate and chocolate. Okay, now let's go with what Carly feels. Carly likes strawberry and banana equal, but chocolate twice as much. So what do we always do when they say twice as much? 2x, huh? So both these chocolate parts are 2x and both the strawberry and banana are just x. Does that make sense? See how the overall chocolate came out 4x, that means? That's what I was talking about. But anyway, you can just do it this way. I think that's easiest. Just break it up all equal. The chocolates are 2x, strawberry and banana are x, because that's how Carly, that's the Carly cake anyway. That's not how Dale feels. We'll get to Dale in a minute. That's Carly's feelings on the cake. Okay, now, you add all those up. Remember, you add them up, 2x, 2x, x, and x. And what do they all add up to be? What's that cake worth? Oh, 18. 18 bucks, right? So do a little equation there. What's that? 2, 2, 4, and 1, and 1, 4, 5, 6. 6x is 18, divide by 6. X is 3. Tracking with me? So now we go back and we stick a 3 in for x. So coming back over here, 2 times 3, this would be $6. This would, right? You see how I got that? I just put a 3 in for x. 2 times 3, $6. And this is just $3. And this is just $3 because they're just x and x. Everybody tracking with me? I put 3 in for x everywhere. So that means to Carly, each of the chocolate quarters is worth $6, and the strawberry and banana quarters are each worth $3. That's 6, 6, 12, 13, 14, 15, 16, 17, 18. That's the whole cake. Fitting her value system on that. Yeah?
When you divided the 6x by 6, what did the 6 represent?
I got the 6 because of 1, 2, 3, 4, 5, 6. Yeah, I was adding up those extra. What's up? Yeah, so I was trying to get the x alone. Yeah, let me back up on that a little bit. Yeah, so whenever you got all the x's in for the cake or whatever, you break it up. You just add them all up, 2, 2, 4, 1, 1, so 6, and then I just add those up, 6x. And then to get x alone, because that's always what you got to do, solve for x. That is 6 times x. So the opposite of times, you have to divide on both sides. So I'm just dividing on both sides. I'm doing that to get the x alone on that. So x is 3. So, okay, what's the question then? Carly, what does it say here? Carly, in Carly's eyes, the strawberry quarter. Oh, well, that's $3, huh? Strawberry quarter's $3. See? Good for Carly? Let's do Dale, huh? So come on down for Dale. Like that. So again, chocolate, strawberry, banana. And how does Dale feel? Dale feels differently. What does Dale think? Dale likes chocolate 3 times as much as strawberry, and he values strawberry twice as much as banana. So that means you have to start with the lowest to be x. So what is Dale? This is the Dale cake now. That's how Dale feels about the cake anyway. What is Dale's least favorite flavor? What's his lowest choice, last choice? He likes chocolate 3 times as much as strawberry, strawberry twice as much as banana. What's his last choice? Banana. So we let that be X. And then you kind of build up from there. Does that make sense so far? So banana's the lowest. You start with the lowest, that's X. And then what does he feel about strawberry compared to banana? Twice, right? So 2X. Good so far. And then what does he feel about chocolate compared to strawberry? 3 times. 3 times? Yeah. Yeah, 3 times. 3 times. So 3 times what? 3 times strawberry. He likes chocolate 3 times strawberry. So 3 times 2X. 6X, 6X. You see the trick there? It's not just 3X. It's not 3 times banana. That would be 3X. He likes it 3 times as much as strawberry. Right? Banana's lowest. Strawberry's double that. And chocolate is 3 times strawberry. So 3 times 2X. Each of those is 6X. See how I'm coming up with that? And now you would know what to do, right? Just add up all those X's, equal to 18, solve for X. So let's do that. Add up all those X's. So get this out of the way here. So add them up, what is that? 6X, 6X, 2X, and X, and they all add up to 18. What is that? 6, 6, 12, 13, 15, and 1 is 15X. So I just added up all the X's. 15X equals 18. I got to solve for X. Got to get X alone. And so last step to get X alone is divide by the 15. And you should calculate, what is that? 1, 3, 1/5, 1.2? 1.2 on your calculator. 1.2. And now take that X. Well, what do they even want? Let me read the question now. Chocolate half. They want to know what the chocolate half for Dale. Chocolate half. So take the 1.2, put it in there for X. Put it in there for X. So this would be 6 times 1.2, which is $7.20, $7.20 for that part. And then same thing here. It's going to be $7.20 for each chocolate quarter. Add them up, $14.40 for the whole chocolate half. D. Is that too quick? See what I did there at the end? So I just added up all the X's. The whole cake adds up to 15X. And the whole cake's worth $18. Divided by 15, 1.2 for X, and then plug in the 1.2 everywhere you've got X. So 6 times X, 6 times 1.2, $7.20 for that chocolate quarter. Same thing for the other chocolate. They're both were $7.20, both the chocolate quarters. Add the two up, $14.40 for the whole chocolate half. That's what that's worth to Dale. So that's pretty tricky. That's a pretty tricky cake problem there. Questions I can answer on that? Can we move on? You good? It can't be much harder than that. It's close to the most difficult. Oh, there's another one with Dale. Oh, come. Okay, so again, let me go back to the Dale cake again. The Dale cake was like this. And this was strawberry, banana, chocolate, chocolate. And it was X, 2X, 6X, 6X. And I added up 15X is 18. Divided by 15, X is 1.2. Plug it in. So this is 720, 720. If you plug in 1.2 here for X, you get 240. This is the monetary value. And here it's 120. Okay, so now what are they asking me? They're asking me for this piece. Now, what is that piece? 45 degrees. That's half a 90, isn't it? So do you understand what they're doing basically when they ask me that? They're taking half of this piece and half of that piece and making this thing out of them. You see that? So half of the 240 and half of the 120. Make sense? So you just take the 240 and you divide it by 2, and the 120 and you divide it by 2, and add those up. See how they're doing that? They're taking half of this piece, right? This is 45 degrees, which is half, and that, because this is a right angle, right? These quarters are 90-degree angles. So 45 is half that. So half of 240, that's 120. Half of $1.20, that's 60 cents. Add those up, that's $1.80, which is answer A. That's what that piece would be worth to Dale. We okay on that? Is that good? Question?
I had a comment. I don't know if anyone else had the same confusion, but when it talks about how, like Carly, for example, how our values are differently. She says chocolate is more valuable than, or twice as much as strawberry.
Right.
I was thinking the chocolate part of the cake is twice as much as the strawberry part of the cake, instead of picking up the flavors in general. So so that's, I didn't connect that 4 times as much.
Yeah,
So, yeah.
I know, that's the real trick.
Be careful
Yeah,
with that.
yeah, really good point. Yeah, so everybody notice, if they give you one piece, like a chocolate piece that's not the same size as the other pieces, that's why I cut it in the middle so they'd all be the same size. Yeah, so before you do any work, make them all the same size. Yeah, because otherwise it really messes you up. That's the extra wrinkle on that problem. That's why we do this practice thing, because I want you to not be surprised next Tuesday, right? Today there's surprises. I go over them with you. Next Tuesday, no surprises, right? That's my aim. So is that good? So you'll know what to expect. All right, good. Just get the cake work done today. Let's see. The cake ones are some of the hardest, though they are. Whoops, what did I just do? Come on, that one. There we go. All right, so now we're doing the Carly cake again. Which of those is if Carly's the divider, which will she do? All right, back to the Carly cake again. What was the Carly cake? So, like this, chocolate, strawberry, banana. I can't remember now. What did Carly do? Oh, Carly was 2x, 2x, XX. Okay. It was 2x, 2x, XX. The X came out to be 3, so this was a $6, $6, $3, $3. Okay, there was the Carly cake, right? That was Carly, her value system. Okay, now, it's saying if Carly is the divider, which of the following will she do? Now, what does the divider always do? Remember what the cutter always does? Cuts it fair in their value system because they get last pick. Remember, that's the general way you divide a cake or a cookies or whatever. You get one person cuts, the other person picks which half they want. That makes the cutter be fair because they know they get last pick, right? So that what they're really saying is, which one of these will be fair in Carly's eyes? That's when they say Carly's the divider, that's what they mean. So in other words, to Carly, would cutting right here and this half, would that be fair in Carly's eyes? Would she do that? Because she's going to do what's fair in her eyes because she gets last pick. If she's the divider, she gets last pick. So would she do that? Is the chocolate half of equal value to her as the strawberry and banana put together? No way. The chocolate parts are, they're $6 each. The chocolate half's worth $12 to her. She would think this is worth $12, and this guy's 3 and 3. These together are only worth 6. She wouldn't do that. She'd be scared to death that the other person would pick the chocolate half, and she'd lose more than half the value. Right? So she wouldn't do that. Would she do division 2? I know that's a weird one. Let's come back to it. How about division 3? Would she do division 3? This part's worth $6. This is 6, 3, 3. No way. Because this all together would be worth what? 12. And this is only 6. That's the 2 chunks she would be breaking it into. They wouldn't be equal in her eyes. So she will not cut something unequal in her eyes because she's scared she'll get the worst half. Last pick. So it's probably division 2, right? This is where you would, if you're running out of time, think, I bet it's division 2. Now, how do we be sure? Well, what they're doing is they're doing the whole quarter, this quarter right here, which is $6. And then the other $6 piece, they're breaking in half, see? So that's $3, $3, right? See how that $6 is broken in half? She's got a whole quarter for 6, and then 3 and 3 she's breaking up. And these guys are also 3. So this part all together is worth 9. This part all together is 9. Yeah, she would make that cut. Because to her, that would be equal value. She would think each of those is worth $9. Pick whichever one you want. I'm happy with last pick, she would think, because she thinks they're equal. So she would make division 2. Good? One more cake. Malia buys a chocolate strawberry vanilla cake. Blah, blah, blah. $14. Cuts the cake. Blah, blah, blah. Are there several? Is it just number 5 or is there more? Just number 5. All right. So I don't need to worry about anything else. Just answer this one. We're good with the cake. Okay. So what is it? What is the value of piece 1 to Malia? All right. Piece 1, if you can tell on your handout, it's half of the overall white, isn't it? See what I mean? This right here. See, there's extra white here and extra white there, which together is the same as the amount of white we're taking. It's half the white. Do you see that? If we just figure out the value of this whole white chunk, then we can just cut it in half. And we have that piece 1 that she's grabbing. Does that make sense? So how do we do that? What does it say up here? $14, oh, chocolate, twice vanilla, vanilla, twice strawberry. Which one do we start with? When they give us like a chain of likes, which one do we start with? The lowest one, right? You always start with the lowest one. So what is her least favorite? Strawberry, right? Strawberry. So that's where your X goes. Which one's strawberry? This one. Okay. That's strawberry for her X. Vanilla, she likes twice as much as strawberry. So vanilla would be 2X. And chocolate, twice as much as vanilla. What's that going to be?
4x.
Good. 4X. Getting the hang of that? Can you read that 4X up there? This one's 4X. Right, so you always start when you have the chain of likes. Start with the lowest, strawberry. Vanilla's twice that, and then twice vanilla, 4X is chocolate. Okay, so we got that, and then add those up. 4X, 2X, and 1X. That's 4X, 2X, 1X, and that adds up to be $14. That's 7X is $14 divided by 7. X is 2. So put a 2 in here. 4 times 2. 2 times 2. 1 times 2. So what do you get? What are those pieces worth? This is $8. This is $4. This is 1 times 2, $2. That's what those various chunks of the cake are worth. Good so far. And then this piece 1, does everybody see that piece 1 is exactly half of the white? Because here's the entire white. Can you see it? There's this entire white piece. And they're taking the middle chunk of it, aren't they? So they're taking the middle chunk of the white. So basically it's half of the value of the white. So the value of all the white is $4. Half of 4, so 4 divided by 2 is $2 worth of cake. B. Piece 1 is worth $2 to Malia. Is that good? Look, you can do the cake thing next Tuesday? With a little practice maybe? Questions before I move on? Good? Okay. So number 6, 3 players divide. 3 players, 1 divider, 2 choosers are going to divide a cake fairly using the lone divider method. The divider cuts the cake into 3 slices. Right. Suppose the choosers value the slices. All right. So okay, how many people play in this game? 2 choosers, but 3 players altogether, right? 3 players altogether. And so what's a fair share in this game? Remember, fair is always fair equals total divided by number of people. So in this case, it's 100%. We don't have any money or anything else. We don't even know what it is they're dividing. Or it gets it to cake, but we're not even seeing the cake. We're talking just percentages, right? So the total's 100% divided by 3 people. If you do that, you get 33.3%. So that means fair in this situation is any percentage that's 33.3 or greater. Remember, we always determine what fair is by total divided by number of people, right? That's what you would think is fair. If you and if you and 3 other friends, 4 of you, found a treasure somewhere, you would divide by 4, right? That's what is fair. So you always divide by the total divided by number of people. So 100% divided by 3, 33.3%. Okay. Now, so therefore, I'm going to circle any of those percentages that's 33 or more. So I guess that would be the 40, the 37, and that's it. Just those 2, huh?
Ours is different.
Oh, do you have a different problem? Oh, that's right. I changed this one because I don't like my problem. And I'm glad I did because mine's a little goofy. I changed yours. That's right. I forgot to put the new one online. I changed yours. Yeah, you got a better one. What yours says? Everything else, but it's 30, 40, 30? Top is the same. Yeah, I changed the bottom, right? 32, 32, 36? Yeah. Thanks. So yeah, yours says 32, 32, 36. So only this one's fair, and that one's fair, huh? Anything 33.3 or more. Those two, good. Okay, so then, if that's the case, which of the following, are the options the same? No, I mix up the options too, so don't pay any attention to this. So what's the answer then? Basically, chooser 1 gets S2, huh? And chooser 2 gets S3. Chooser 1 gets S2, chooser 2 gets S3. So it's B?
Yeah,
B.
divided this one.
Yeah, that makes sense on that? So just 100% divided by 3 for fair, and circle the fair. All right, I'll move along. All right, so how about the first one? Assuming that all players play on stage, which one was the divider? Yeah, because D always stands for divider. No, I'm kidding. It's because the divider has the same numbers, right? Divider's always the one with the same numbers all the way, because they cut it fair in their own eyes, so it was D on that. All right, we're going to need to stop because the rest require a bunch of adding and all that. Let me give you a clicker and we'll be out of here. In fact, there it goes. There's the clicker. No, it's not on the screen, but it's on the computer. Click. A for Apple. A for Apple. Got your free 10-point. 2 free 10-point quiz today. We're done there. Yeah, don't wait. Well, then, if you did that, press A one more time. It'll take your last one. But yeah, I get that every now and then. Especially I taught one with 90 people, and every now and then there'd be a wrong answer on the preview. Have a good day. We'll go over this more on Thursday. What's that?
Was I marked that?
Oh, it's the clicker. So did you just click in?
Yeah.
You're good then.
Oh, cool.
You're good. Well, we did do that first quiz before you came, so you did lose those 10 points, but you got this one, so you're good.
And I finished the parking lot. I had to go all the way across campus.
Oh, really? Was it crowded out there?
Yeah, I had to park the very back so I got my papers.
Oh, wow. PJ. PJ Jones, you click in?
I didn't have my clicker. I was at.
Oh, I'm sorry.
I was in a rush.
Yeah, it's okay. I won't drop your anything for it, but you do lose those quizzes. Bring those clickers, man.
I'm gonna bring it tomorrow.
Did the team win this weekend?
No, we lost. We lost to American River in overtime.
Oh, overtime.
Yes.
Wow.
Yeah, it hurt.
Okay. Yeah.
Hurt.
Did they?
Our defense on the field the whole time.
Really?
Offense couldn't score.
Oh man.
Yes, well, yeah, next week. We play
Okay.
really battle for the pump.
You playing? Oh, you playing relay?
Yeah.
Okay. Yeah, I know somebody that plays on relay. No, a running back. No, he's a safety like you or Chris is his name. Yeah.
Is it?
Colin Clark or?
He got is he kind of tall?
Yeah, kind of tall.
I think I know you're talking about.
Yeah.
Chris.
Is it Colin Clark? Is the last name Colin Clark? I think. Ah, yeah. Anyway, Chris, kind of tall. I was moving furniture with him and some other people Saturday.
I think our homecoming is next week.
Is it next week with relay or no next?
No, I don't know.
Gotcha.
But I think it is next week.
Next week. Okay. Got to win your homecoming.
You should go.
Oh, it would be fun. I'm gonna head out to watch my daughter play tennis here in about a half an hour.
Really?
Yeah, my kids are tennis and soccer and swimming.
What's she play at?
Fresno Christian.
Oh,
Yeah. See you, PJ.
all right.
Thanks.